Hello friends, my name is Justice. In this video, we shall be discussing how to generate random numbers in R. I know that some of us are familiar with how to do this in Microsoft Excel, but before we proceed, let me briefly show us how to do it in Microsoft Excel. In Excel, it is possible for us to generate random numbers, and we can just use Microsoft Excel functions to do that. So let's look at the round function. This function basically gives us random numbers between 0 and 1. So we've gotten this 0.665145, and we can just drag this to the cells where we want to have random numbers between 0 and 1. So we have this. There's another function we can use if we want to generate random integers in Excel, and it is known as round between. So when we have round between, we have maybe minimum value that we are expecting to be 100 and maximum value to be 200, for example. If we hit the enter key on our keyboard, and we can get this result, and we can just drag this to the cells where we want to have random integers, and basically this is how we can do this in Microsoft Excel. Now let's go to R and also show us how we can do this. Let's now generate random numbers in R. It's also important to mention at this point that R is a high-level programming language, which means that there are some existing functions that are inbuilt that we can use to perform some tasks, and this is just the opposite of some low-level programming languages such as C, where we develop everything we want to do from scratch. Okay, so in order to generate random numbers in R, there are some inbuilt functions that we can use, and we have a typical example of that is runif function. So we can use this runif function to generate random numbers in R. And if we look up for this runif function in the console using the help functionality in R, when we run this, we can see the documentation for this particular function, and it has to do with uniform distribution. And we said that numbers are said to be uniformly distributed if all the numbers in the range are equally probable. Now this simply means that the numbers are equally likely, and it means that they have equal chances of occurring. So when that happens, we say that those numbers are uniformly distributed. Okay, so when we want to look at this, the first thing we need to do is to set seed. So we use the set seed function. We can just use 102, for example, and what this means is that the random numbers that we are generating, each time we run the code, it will give us exactly the same result because we've set the seed, and we also need to run this seed whenever we want to execute that code in order for us to get the same result. All right, so from the runif documentation that we just saw, well, let's see how this works. So a typical example is this, and the n here represents the number of random numbers that we want to generate. This is the minimum value, and this is the maximum value. So this minimum and maximum values here are the default values. Of course, we can also use other numbers that we want as the minimum and maximum values. All right, so if we want to, let's just see a typical example. If we have runif and the number is equal to, let's say, 10, we want to generate 10 random numbers, and the minimum value is let's say 100, and the maximum value is 200. Okay, if we run this and we've set our seed, of course, we get these numbers. So these numbers here are 10 numbers, and they are between 100 and 200. So you cannot see any number less than 100 here, and you cannot see any number greater than 200 here. All right, but we can also see that these numbers are in decimal places. So the class for these numbers in R is the numeric class. We'll look at this much later. So but it is also possible for us to have these numbers without even specifying the names of the argument. So we can have, for example, runif of 10, 100, and 200. And since we have run our seed, we are expected to get the same result. So we'll see that this is still the same result, and this is because R understands that the first item here should be the number of random numbers that we want to generate. The second one should be the minimum, and the third one should be the maximum. Now, if we want to look at this again, we can also see that R unique of let's say n equal to 10 and max equal to 200 and mean equal to 100. This particular line of code and this particular line of code will give us the same result. The only thing we've done here in this particular one is to switch the argument, but then we still retained the name of the argument. So this is maximum 200. The only thing is that we've changed it, so this and this will just give us the same result irrespective of the position. So if we run this now, we'll still get exactly the same result that we got when minimum came first and maximum came second. All right, so it's also important for us to have these numbers as whole numbers, because we can see here that they are numeric, they are float. So but we can also have them as whole numbers. Now if we want to truncate the decimal places, we can simply use the floor function. So if we have let's just copy this so that we can just use the floor function to truncate all the decimal places. So if we use floor and paste this function here, let's just run this our seed and then we run this. So we can see that we've truncated all the decimal places. Now we see that everything that is coming after the decimal point is being truncated. But what do we observe? We observe that this particular function is interested in just truncating the decimal places but not rounding it up to the nearest whole number. A typical example is this. In mathematics, this, if you round this up to the nearest whole number, this is supposed to be 142. Now if you want to achieve that in R, it's as simple as using the round function. So when we have the round function, we can easily paste this value that we've copied. But let's run our set seed first also, so that we'll have the same result. So we just run this, and when we do that, we can see that this is now 142, which is correct. Now depending on whatever we want to achieve, we can always use the function that we want. So this is basically how we can do this. Now if we want to look at maybe revenue, for example, it's also possible for us to maybe generate revenue of say a company that have operated from January to December. So we want to look at the revenue of that country or that or a company in 12 months. So what we can do in order to get that is also, so let's just start by setting our seeds to any number. So this number can just be anything. So we can even use a 206. It can be any integer of our choice. It doesn't matter what it is. Now if we run this seed and then look at a particular revenue, so let's use R unique of 12 representing the number of items we want to, or numbers we want to generate, and then the second input can be maybe 50,000 pounds, and then up to 100,000 pounds. So we have this, we've already executed the seed. So if we run this, we get these numbers. Okay, this is what we have, and we can see that these numbers represent revenues of a particular company for 12 months. So we have 12 numbers generated. Now what can we do again? We can actually, maybe our stakeholders may just want to see these numbers in their nearest 1,000. So what we can do is just to round this up to the nearest 1,000. So let's run this seed again, and we can just copy this, and we have the round function. When we do that, we paste this here, and we can now specify that we want this to be to the nearest 1,000, and that is as simple as including the second argument here, that is -3. So when we do that and run this code, you can see that these numbers are now in their nearest 1,000. So that is basically what we can do, and we can also use another function in R to achieve the same result, or to generate random numbers. And this function is also known as rnorm. So this is rnorm function. We can use this to generate normally distributed random numbers. And we say that a particular set of numbers are said to be normally distributed if they have probabilities that follow the normal distribution. So it simply means that we have a set of numbers that follow the normal distribution that we are aware of, that's always in bell shaped. So what it means is that these numbers are actually close to their mean. They are actually close to their mean. So if we just look up for the more details about the rnorm function in R, for example, we can get some documentation about that. It's telling us that this has to do with normal distribution. And if we just scroll down to see some ways we can use this, we can see that it has also the number, the number of random numbers we want to generate, and then we have the argument for mean and the argument for standard deviation. So here we see that the mean and the standard deviation have been given the default values of 0 and 1. Alright, so let's just see how we can use this. So we are in a situation where we want to generate random numbers for random scores for our 50 students that participated in a particular exam. So how do we do that? We can just set our seed first, and this seed can be, we can just use 41 for example, and execute this code. Now the next thing we can do is also to look at a way of generating the normally distributed random number. So we'll use rnorm, and the number of students is actually 50, and the mean, we can use mean of maybe 70, and the standard deviation of, let's say, 3. Alright, so when we execute this code, this is the number that we have. So we can see these numbers for 50 students in a particular class, and we can see from here that these are also in decimal places, the numeric class in R, and we can just round this up to the nearest whole numbers. So when we run this seed, and we can come down here and round this to the nearest rnorm 50 students, 70 as the mean, and 3 as the standard deviation, and run this. So when we do this, we can see that these numbers has been rounded to the nearest whole numbers. A typical example can be, this first one is now 68 instead of 67.61689, and that applies to all of them. So this is what we have, and then this is what we can do. Now it's also important to mention that it is possible for us to omit a particular argument. So if we want to omit from this array, if we want to omit the minimum value, it automatically takes 0 as the minimum value. So let me just give us an example. So if we have array of I want to generate just 20 random numbers, but I don't care about the minimum value. So what I can do is to skip the minimum argument and say that I want the highest value to be 5. That's the maximum value. So I can just run this and I'll get this result. 20 numbers with minimum now should be 0 because we didn't specify it. So R will automatically take 0 as the minimum, and the maximum value is 5. So we cannot see any number here that is greater than 5. So this is basically it. If you need further clarification, you can just drop them in the comment section. Please like and subscribe to my channel. Thank you.